So the first one is, as you can see, it's not hard. It's just how to use. Just want I just want to check that everybody doesn't have problem in the simple one, because if we do too much the harder part and we miss the simple one, that's not funny. So we know this problem. We want to maximize this angle, right? So let's say this angle here is beta, and this one is alpha. What which the name doesn't matter. And let's say, which do you want, this part or this part as x? Let's say this part as x, right? What doesn't matter which one you choose. So this one, this so PB is x and PA is what? 3 minus x, right? So what we get is basically we know that alpha plus beta plus theta equals to phi, or 180 degrees, which I use phi because well, I prefer to choose phi. You can write 180 degrees, doesn't matter. So the unit will be in radians, but neither here nor there. So we know that tangent of beta equals to 2 over x, right? And tangent of alpha equals to 5 over 3 minus x. So this problem become what? Tangent inverse or arctangent, which which symbol that Professor Iman used in the class? Arc, huh? And with minus one, right? Okay, okay. So I just want to use the same symbol. 5 over 3 minus x plus the tangent inverse 2 over x plus theta equals to phi. So we have theta equals phi minus tangent inverse 5 over 3 minus x uh, minus our tangent inverse 2 over x. Okay, so we derive d theta to the x, the theta dx equals to, and everybody know that the tan tangent inverse x dx equals to 1 over 1 plus x squared, right? This is the formula, right? 1 over 1 plus x squared. So this one we have 0 because constant, minus what? Tangent. So we have 1. Oh, mm, we have minus 1 because this is power of 3 minus x power of minus 1 because it is on the denominator, and we times minus 1 against minus 1 from here, the derivative of minus x, like and What else? And so basically, I want to derive this part 5 over 3 minus x, and we have 5 over 3 minus x squared, right? And then over 1 plus 5 over 3 minus x is 1 square. So far, so good, right? Or I make some mistake? Yeah, so far so good. And this one, plus or minus, it depends on what's plus, because it's still in the column. Plus derivative of this one is much more easier. Minus 2 over x square over 1 plus 2 over x squared. Okay, so we simplify the things. Minus minus plus, so 5 over 3 minus x squared, 1 plus 5 over 3 minus x squared. Oh, maybe it's better if I write as plus 25 over 3 minus x squared. This one become minus 2 over x squared plus over, sorry, 1 plus 4 over x squared equal to 0. And well, basically you just do what everybody always do. Now we have what? Here we have 5 over 3 minus x square over 1 plus 25 over 3 minus x square minus 2 over x square over 1 plus 4 over x square equals 0. Right? Check again. Yep. And so this one is equal to 5 over 3 minus x squared plus 25 minus 2 over x squared plus 4, right, equals 0. So we can just put here, so this one the same as this, and we multiply. So we have 5x squared plus 22 equals what it is, to this guy plus 25. Do I make mistake? Hopefully not. 5x squared plus 20. I'm afraid making mistake, but hey, we do what we do. Hopefully doesn't make any big mistake. Hey, equals to 18. 2 times 6 times 2, 12. 12x plus 2x squared plus 50. Okay, so far so good, I guess. So we have 3x squared and plus 12x minus 30 minus 48 equals 0. X squared plus 4x minus 16 equals 0. So x will be minus 4 plus minus square root of 16 minus AC minus 4 AC plus 4 times 16 over 2. So we have minus 4 plus minus 4 square root of 5 over 2. So the answer will be 2x will be what? 2 square root of 5 minus 2. I'm not sure is the answer correct?
I'm not sure because
Not sure, okay?
it doesn't make, but my calculation is wrong. But I don't know about yours.
Okay, so I also not so sure the answer is correct, but hey, you get the point, right? Uh, you get that. This is how we find the. Oh, this is, but it's just x. So for theta, remember that you must put uh, x is basically, or we must know that tangent b equals 2 over x. So you you solve this, you get b, you get beta, you get alpha, and finally you will get the theta. It will be long, and I think you got the point. So any question so far? I don't think so, right? It's pretty easy, just complicated, and some problem in the exam I think will be follow this line. Easy but complicated. And next one is, I think, the reverse of the previous one. So it is not complicated but not easy either. So okay, does this function la 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 has an absolute maximum? If so, find it, and how about the absolute minimum? Okay, so first we have function with absolute value. This one. So what I think the best practice if we have this kind of function, okay, I just write, okay. I think the best practice if you have function with this kind of uh, absolute eh, absolute value is to divide it into two parts. That's makes our life much easier than deal with this. How to derive the absolute value? For me at least it's nightmare. But if we can divide into two, that is equals to a 10 times x minus 2 minus x squared for x, what? For x bigger than 2. And this one will be e to the what? 10 of 2 minus x squared for x smaller than 2. And what for, well, you can just write this or this, so doesn't really matter whichever you choose. I prefer to have the third one, e to the minus x squared for x equals 2. But doesn't really matter. It just show you how important your understanding in what is the domain. Divided function to the domain will make the problem become much, much, much more easier. I think. At least I think. Mm, I think so far so. Now. When we derive the function, so okay. Now, if the question is that does this function fx uh, has a derivative, I think my answer will be no. Obviously, it doesn't have derivative because it is not continuous, right? We can see that it is not continuous. It's obvious. But because the question doesn't ask whether it has a derivative, but does it have an absolute value, right? So the answer will be maybe yes. Maybe it has the absolute value. So to do that, we will check what is the absolute value for that. So basically what we do is we derive the function per its domain. So for first domain, so A for first domain, the for x bigger than 2, the df dx will be what? Will be 10 minus 2x to the e 10x minus 2 minus x squared. So far so good, or am I make mistake? No, right? So far so good, right? I think I'm sorry if I make mistake because I learned calculus like 12 years ago when I was in the same like you in the first year. So, oh, okay. Now so this one, if we want to find df dx equals 0, it's easy, right? We just make this one equal 0. So we have x to x a. Sorry. Equals to 10 min 2x. So x equal 5. Okay. Now for the b is when x equal 2, then well actually it's illegal, so I must write first it is illegal. Obviously it is illegal because it's not, because the domain is clear at x equals 2. So well, the answer whether it's illegal or not is actually, it's more complicated than that. It is not will be answered in the calculus. It will be learned in analysis, and thank God we as engineer doesn't learn analysis, real analysis. So just so you know that it's not quite legal actually, but it's helpful for our problem. Do you get what I mean? So this one will be df dx will be minus 2x a minus x squared, and obviously there is no there, it is not the same as 0, so we just don't care about this thing. And the c part, the c, okay. The c part, why c become something like this? No, c, the c, well, we know that the df dx in c will be what? Will be minus 10 minus 2x e to the power of 10 times 2 minus x squared. So when it is equal to 0, it is the same as minus 10 minus 2x. So x will be minus 5. Now we have two candidates, x equal 5 and x equal minus 5. Sorry, I lost my battery. Good. Now we will check. How to check this thing? So we have here a equals what? A equals in a we have df dx equals what? Equals a 10 minus 2x e to the power of 10 okay, x minus 2 minus x squared, and we have our candidate point at x equal 5, and we have b. This is when x bigger than 2, and this is when x smaller than 2. We have df dx equals to 2x. Sorry. Minus 10 minus 2x e to the power of 10 2 minus x squared, and we have candidate and we have point at x equal minus 5. Now when we check whether it has absolute maximum, what we do usually?
Check on the number line from left side and right side whether it's or
Okay, so what we usually do is we use a second derivative, right? Second derivative to check whether the function is convex or concave, right? Does Professor Iman use this term?
He use like
What term?
on okay, up and down, upward and down.
Okay. So Prof. Iman say this is up and this is down, right?
Yep.
So this is up, this is down, or you can say it's convex and concave. Sorry. Now, to simplify the problem, later we will show that basically d2 dx, you can check by yourself, but I don't have time, sorry. The second derivative of both value will be negative, so all of this function is downside. Oh. But because it is not continuous, it's become more interesting. So what we can do is we just compare. We put this to the original function. So f5 will be what? E to the power of 10 times 5 minus 2 minus 25. So it will be 30 minus 25 e to the 5. While f minus 5 will be what? E to the power of 10, 2 minus 5 minus 25. So this one is 7, right? 70 e to the power of 45. So we have the global maximum at minus 5. What I want to say here is basically I know this answer because I draw the picture. That's how important is graphing the graph of the equation, not only for you to just to know what is the picture, but to get the answer, because otherwise you can easily mistaken that you say the answer will be at x equal 5, because it seems that it is maximum value, because it is the second derivative is negative and the first derivative is 0. But as you know, basically this function doesn't have derivative, so we must treat it the function for its every domain. So when it is on every domain, it has a derivative. Okay, the last one, I think I will be very quick here. What you can do here is basically using it, just simply we have fx equals to sine x minus cos x. So we have dfx dx. Just like before, we divided into two parts. We have a when sine x bigger than cos x. So df dx will be cos x plus sine x equal to 0. So it is when sine x equals to minus cos x. And this one, and the b part is when sine x smaller than cos x. and we have df dx will be what? Cos x, derivative of cos x will be minus sine x minus cos x will be 0. Okay, so here the function is cos x, fx is equal to cos x minus sine x, right? Sin equal to 0. So basically sine x equals to what? Minus cos x. Yep. When it happened, well, this is happen basically here and here. It is when the function is at the degree in the degree of three quarter of phi, right? Pi over 2 plus 4 plus a quarter, and this one at 2 minus a quarter. So what is? Or 7 over 4 phi. And later you will find that either sine x equals or n cos x equals to minus half, or vice versa, sine x. I forget which one which, but and cos x will be positive. And yeah, here you get, so cos x minus sine x will be square root of 2, and the same here will be sine x minus cos x will be square root of 2. So I think that's answer our question. And in the exam you must write much more better than what I do, because I don't have time here to make it prettier and more systematic, but I hope you get the point. Is there any question so far? Why just use 5 and minus 5 to check the point? Okay, a good question from Likai. Okay, because it is when the derivative equal to 0. You can check in another point. So basically, 5 and minus 5 is what we call extreme point. So they can be maximum or minimum or else. We will have another extreme point at the border, and the border will be infinity and minus infinity. This is when the absolute minimum will happen. But so we have four. In this case, we have four extreme point: 5 minus 5 because the derivative equal to 0, and 2 in the border. And we will see later the border will actually 3 in the border. Infinite, positive infinite, negative infinite, and the 2. And we have checked in the 2, if you remember, and the answer will be not as big as the 5 or minus 5. So um, that's why I use 5 and minus 5. You can check in another point, but it won't be bigger than minus 5 because the derivative is not 0. Is it clear? No? I think it's quite clear, right? So I ran out of time, but yeah, basically we need to check in the extreme point, and that's when extreme point happen. Okay, I think that's all. Thank you for coming for today, and good luck, and see you next week. Bye bye. Okay, you're welcome. Thank you. What do you think? It's too slow to.
Sorry.
What do you think about the tutorial? Is it too slow or too?
I think the speed is reasonable already. Yeah. I only like something maybe something else that on my point.
Okay. Yeah, I get it. What do you think? Because I don't find something nice in the videos.
But if you go to Microsoft Store, there's something called one more word, draw word PDF. I think the session is really good already. I really like the questions that we put in
Let me clear that we don't one hour a week is not enough. So you must do your
our own practice.
your practice because well, but then what I want to show is something that I think interesting that
Interesting.
yeah. So oh, you think that when it is the second derivative is negative, then you have the optimal point. Maybe not because in this case there is a point, and I saw how you derive the absolute value. It's not wrong.
It's tragic.
It's not wrong, but it's hard. We can do the easy way. That's
Good morning.
thank you. Okay, have a good one. Okay, thank you. Bye.